So you figured out which way the bicycle went and gave me bonus information how long the bicycle is. Awesome.
What if it was two unicyclists following each other?
Yes. That's the way to foil the police. Actually, that's a good question.
This cannot be two motorcycles.
Could it be two unicycles? Unicycle. Good question. We could foil the police like we said at the very beginning. If I rode a perfectly straight line, you couldn't tell which way we went. Here's a question. Is there another path we could follow where you couldn't tell which way the bicycle went? Or is the straight line case the only one that's possible that with this method fails? That's true. If the thief is going in a circle, we might just have to wait around and we'll see the thief. But now is a mathematical question. Or figure eight. Actually, seriously, would one of those shapes actually give us a pair of bicycle tracks which we couldn't tell which way we're cycling around?
Yes, so your wobble has to be perfectly harmonized with like the length of the cycle.
For a figure eight or for a circle?
For a straight line, for going in one direction. So if you're going in one direction, see he's wobbling sort of, some of them are really big wobbles and some are smaller, but if you're wobbling it sort of exactly in harmony with...
Oh, so you're saying you could do like a sine curve, a nice wave, smooth wave, with the right period and amplitude, that somehow if that was the back wheel, the front wheel would make a shape that has a nice, nice symmetry to it and makes everything, it's just too nice that you couldn't tell which way you're going?
That's how mathematicians write.
That's how mathematicians write. Well, first of all, that sounds hard to me, because I don't know what a sine curve is as an 8th grader. But what about circle? If I rode in a perfect circle, what would my tracks look like? Perfect, yeah. We're now mathematicians. Everything's perfect.
Two concentric circles.
Would it be two concentric circles?
Yeah.
Let me give you some whiteboard space, so I'll just roll up this part of the picture. There we go. So, back wheel was black. So if I force the back wheel to go in a perfect circle, what's the front wheel track, which is red?
Yeah, bigger circle.
I would say a smaller circle.
Or same size circle?
Well, it can't.
Because
It can't be a bigger circle. It would never touch the inside circle.
What is the smallest circle you could ride? If the back tire was standing still, the front tire would still be out.
What's the smallest circle I could ride on my son's scooter? By the way, he's 23 now, so that's why he didn't
That's why you got to roll with the handle that goes up.
yeah.
They could be two.
I mean, I could just, you tell me what's the smallest circle I could draw on the back wheel? Just a pivot?
Yeah.
I mean, it's pretty cheaty, but kind of. In which case, the front wheel track is a circle that's...
Yeah, like a point in the center, a circle on the outside.
So what if I force the back wheel of the scooter to ride along that circle? What would happen? Would it be a larger circle? All right, so the question is, so I get a larger circle, wasn't, for that scooter it's bigger than that, but let me just draw that for now. Does your method of telling which way the bicycle went actually fail on that diagram there? In what way?
You can go forward with that.
I mean, I need the tangent line argument, that's what your argument is. So what's happening with tangent lines in that picture?
They're symmetrical.
Go back to where you started.
Yeah, so I drew a tangent line somewhere. It could either be coming this direction, hitting the front track that way, if I assume I'm going this direction. But because of symmetry, I can also do that. And by the same argument, all right. So that curve definitely fails. So straight line, you couldn't tell which way the bicycle went. Circular paths, you can't tell which way the bicycle went. What about a figure eight? What about a sinusoidal curve? What do you think? Show me. Show me one.
I'm just saying, I think mechanically there probably is some intersection between the length of the length and the curve that we get.
Okay.
Oh, so you're saying that if you kind of do a bunch of figure eights, you can get out. You're saying, if I go...
I know what I'm saying. Someone else did figure eight, and someone else did some wavy stuff.
You're saying right as soon as I hit the...
Do it. Show me. I don't know what you're talking about. So
You go like this. I can pick any way to get out, right? Because right here, I go like this.
All right. Okay.
and then I do this, and then I'm out, right? But, oh crap, I'm not out. Damn it. Yeah, you can't, I don't know.
Just that.
So, hang on, is two kissing circles good or not good?
I was thinking you can come along this way,
Yeah?
and then go like
You have
this,
to change the other circle.
and then go like that. But I think when you hit here, it means that you're either here or here.
Right.
Yeah, but what if the circle's diameter is the same?
And then when I
length as
when I
the
go
bicycle?
like here, as soon as I hit here, it means that I gotta be here, which is impossible, or here. So I've told which way I've gone by this way.
But what if the width of the circle is the same as the length of the bike?
So if the width of the
Either
circle,
diameter or the radius.
yeah. If the circle was as wide as those two wheels, is that right? Diameter, yeah.
How would you ever bike like that?
This is an idealized world.
Exactly.
It's mathematicians.
Mathematics doesn't solve real world problems. This is figurative.
Oh, that's why it's figurative.
All right. I'm going to just tell you something right off the bat. I would love to see a figure eight that is impossible to tell which way the bicycle went. I'm yet to see one in my life. I would love to see a wavy sine type curve that actually has everything matching perfectly so you couldn't tell which way the bicycle went. I personally have not been able to construct one that does the right thing, nor have I been able to argue or prove that one couldn't be constructed. The answer to my question is I have no idea if the circle is the only path that you couldn't tell which way the bicycle went. And I would love for you guys to actually play with it and show me an example of another example where you could tell which way the bicycle went, or prove to me it cannot be done. This is it.
You need another dimension.
Actually, you could so do this in the third dimension. Just do a piece of wire just going in the air, and then just do the tangent line to that wire everywhere. Just go out some distance. That'll be the front wheel track.